So with number 1, we got g of x is equal to 2x. The only thing that we're doing here is we are vertically stretching by 2, which means that we're elongating our line. We're increasing our slope from 1, right? My parent function has a slope of 1. Let's just write it up here. My parent function has an m of 1 and a b of 0, right? Well, this function has an m of 2 and a b of 0. So I'm still going to have my b value in the middle, but instead of rising 1 and running 1, I'm going to rise 2 and run 1. Rise 2 and run 1. All the way up and all the way down. Okay, and we can see that we didn't change anything about the alignment of our graph. All we did was steepen it a little bit by changing our slope, by stretching it up by 2. Anybody get that right, number 1? Good. I'm glad. Number 2, we're not changing the slope at all, but we are changing where our line is positioned. So we still have an m of 1, but now we've got a b value of -4. We're going down. We're translating, let's be specific, we're translating down 4. So I'm just going to take my line, I'm going to go down 4 and make a dot. I'll go up here, down 4 and make a dot, down 4, make a dot, and then I'll fill in all those little blanks, right? That one's not too bad. And all we did was just move our line down. Did you guys get anything different for number 2? No? What does the number inside the parentheses tell me I'm doing? Translating left and right. Thank you, Chloe. Does your graph still look like this if you went to the right?
Yes.
Yeah, because look, my x-intercept is still 4. So I could also say I'm translating 4 right. Remember, a minus on the inside, we think opposite. So 4 to the right. Right? So going down 4 and going right 4 in this case are the same thing. Does anyone remember why they're the same thing in this case? We talked about it yesterday. Aldrich?
Because there's nothing to distribute.
Because there's nothing to distribute, right? We don't have any sort of stretch or compression factor. So if we're not changing our slope, we're keeping our slope 1 and we're just moving it around, the direction doesn't necessarily matter, okay? When we get down to something like number 7, though, it's definitely going to matter, right? But first, let's do number 4. Now, number 4, I'm doing a couple things. I see that I'm vertically, what, stretching or compressing? Stretching. How do I know I'm compressing?
If it's less than 1.
Less than 1, more than 0.
Absolute value.
Yeah, that's right. The absolute value of A is less than 1, but more than 0. A fraction, that's not something like 3 over 2, right? So I'm stretching by 3. What does that minus sign tell me I'm doing?
You're translating across the x-axis.
We're reflecting, not translating, reflecting across the x-axis. Okay? That just means we're flipping it over, right? So I'm vertically stretching by 3. Now my slope here is -3. I still have the same b value, right? There's nothing else happening here. I'm not translating, so I stay at the same b. But instead of going up 1 over 1, I'm going to go where? Down 3 and right 1. Not left 1. Down 3 and right 1. Up 3, left 1. Up 3, left 1. And I get this function right there. Looks like that. So not only did we get a lot steeper, but we completely flipped our graph over. Whereas before we were going uphill, now we're clearly going downhill from left to right. Does that kind of make sense? Number 7, we got a lot that we're doing. We're doing all 4 things. So this minus sign tells me I'm reflecting. The 2 tells me I'm vertically what? Stretching or compressing? Stretching. It's greater than 1. Doesn't matter if it's negative. The negative's a reflection. Minus 3 tells me I'm going where? 3 spaces.
3 units right.
Right 3,
Right. Yes. Yeah.
and minus 4 tells me I'm going
Down.
down 4. Okay, now that we figured out what we're doing, what do we want to do now? There's a couple things we could do. The easiest thing to do would be what?
We can turn it into slope intercept.
That's right. Just simplify this to slope-intercept form. If I distribute this, I get negative 2x plus 6. 6 minus 4 is 2. Negative 2x plus 2 is my slope-intercept form. It's a lot easier for us to graph that than it would be to take this function, stretch it, and then move it 2 spaces. That's a lot of work. So now I just know I plot my b at 2. I go down 2 over 1, down 2 over 1, down 2 over 1, all the way across. And there's our line. Take a look. From the origin, if I go to the right 3 and then down 4, I have a point on that line, right? So if I didn't want to convert this, if I wanted to just follow my steps, here's what I could have done. I could have gone from the origin, right 3, down 4, and then used my a value minus 2 by going down 2 over 1. Up 2, left 1, up 2, left 1, up 2, left 1. And you see that we have all the same points of that line. So either way you want to do it is fine. All right? Any other questions on the front before we move to the back? Okay. 13 and 14 on the back. Number 13. Each transformation to the right is performed on the line with the equation y equals negative 4x minus 4. So now my parent function is not y equals x or f of x is equal to x. It's y equals negative 4x minus 4. So we got to think about this is my starting point. This is my parent function for this specific problem. Let's see what's going to happen if I vertically translate it 3 spaces up. Well, what's that going to change about my equation? Alex, what's it going to change?
Your b value.
My b value, okay. So if my b value is at negative 4 and I go 3 spaces up, what can I do with that negative 4?
Add
Plus 3. Okay, and what do I get?
negative 1.
Negative 1. Does my slope change?
No.
Nope. Y is equal to negative 4x minus 1. I see how this could be confusing. Did you guys go back to the parent function for b, or did you use the equation from a?
The equation from A.
Give me a thumbs up if you used the equation from a. Give me a thumbs up if you went back to the parent function. Okay, so 9 people actually did it. Either way.
Wait, what happened?
It doesn't matter.
So wait.
The intention was to go back to the parent function. I should have made that more clear. That's my bad. So if you used a and then used b for c and then used c for d, it's fine. I see why you would have done that. So don't worry. Yeah.
So for number 13, you would have y equals 4x minus 1 and y equals 4x minus 6 for a and b.
Yeah. Andrew?
Do we have to turn it into slope intercept form? Or can we leave it as like g of x equals...
Oh, I mean, if it gives you the slope-intercept form, yeah, just keep it in slope-intercept form. Y and g of x are the same thing, right? So I could say g of x is equal to negative 4x minus 4. It doesn't really change anything about what the function is, but if you prefer that, that's fine. I don't care either way. So if I'm going back to the parent function, 2 units down means I'm subtracting 2 from there. I get negative 4x minus 6. Now, if you went from a, it would be y equals negative 4x minus what?
3.
3, right? So either one is fine. I will make sure the test is definitively specific about what you should be doing. So just make sure you know how to read. I messed it up here, though. That's my bad. If I'm going to divide the slope in half, again, I'm going back to the parent function. What's my slope from the parent function?
-4.
Well, what do I get if I divide -4 in half?
-2.
-2. Or if you took, you know, the previous one, y is equal to -2x minus 3. On the test, you're going to go back to the parent function. These are all going to be separate. Again, I'll make that clear. So I'm going to, yeah, you know what I'm talking about. If I double the slope, if my original slope is -4 and I double it, what is it now?
-8.
-8x minus 4. Or if you took c, you get -4.
Write the new equations for each equation.
Any questions on 13? Anybody get all those right? Cool. Good. Abigail, Colby, Tristan, Raven, Christian, everyone else that has the thumb up. Now, number 14, I got y is equal to x plus 5. If I increase the slope by 3, what's my slope going to be? 3?
3x.
4x. What's my slope here?
1.
1. If I increase it by 3, now it's 4. Right?
Oh.
My slope's not 0. If my slope was 0, there wouldn't be an x at all. So if I increase my slope of 1 by 3, well, now it's 4. Okay? We're going to forget A exists. I'm going to go to B. I'm vertically translating 5 units down. What would my equation be for that? Y equals x. That's right. We eliminate that B value altogether. Christian, don't do that. What if I take this equation and reflect it over the x-axis? What's going to change there?
The x will become negative.
X becomes negative. Does my B value change?
No.
Nope. And if I shift down 2, well, now my B value is 3. If I double my slope, what is it? 2x. Again, if you did it the other way around, I understand. That's my bad. Don't even worry about changing it as long as you understand that we're going back to the original each time. Again, on the test, I'll make it very clear that's what you're doing. Okay? Any final questions? Cool.